Hi everyone. So today I want to talk about what are some of the values of the Rayo's function. So this video has been requested or asked by actually many people, and I also have been thinking about this for some while. So I decided to do some research, and I actually found some results. So now let's get started. So of course the Rayo's function, Rayo n, is defined using the first order set theory, which is basically the language of mathematics. So of course it's quite different from the regular English or any other language that we speak. So for the first order set theory, they are using symbols like these. So these are some of the examples of the symbols that are used in the first order set theory. So again, this theory, they are not using symbols like 1, 2, 3, 4, or plus, something like that. It's quite different. Again, I'm not gonna explain to you what these means. You can Google it yourself. And so in briefly, basically, in order to write 0 using the first order set theory, basically you have to use uh, 10 symbols or around 10 symbols to do that. So it's very inefficient to write small numbers. So for number 1, you have to use 30 symbols, and for number 2, you have to use 50 symbols to write number 2 using the first order set theory. So again, the Rayo's function is basically um, the n here. You put n here. N is basically the number of symbols you can use, and Rayo's n, the result of that is, it means the smallest number that is bigger than the biggest number you can make using n number of symbols. So what that means is that Rayo 0 is 0. Um, and for Rayo 10 is bigger than or equal to 1. So we can look back at here because using 10 symbols you can make 0, and of course Rayo 10 it means the smallest integer that is bigger than the biggest number that you can make with 10 symbols. In this case is 0. So you what is the smallest integer that is bigger than 0? That is 1. So therefore Rayo 10 is at least equal to or bigger than 1. And for Rayo 30, it's at least bigger than or equal to 2, because again, you need 30 symbols. Using 30 symbols, you can make 1 at least. And Rayo 30 is the smallest integer that is bigger than the biggest number you can make with 30 symbols. In this case is 1. So therefore Rayo's 30 is 2 or bigger than 2. And for Rayo 50, in this case is greater than or equal to 3, because it's the smallest integer that is bigger than 2. In this case is 3. So as you can clearly see here, as a matter of fact, I think this is quite mind-blowing or surprising to most people, because actually for small inputs of n, so I mean, for let's say 10, 30, 50, you're only getting very small numbers. So even Rayo 50, you only get something like 3, and Rayo 30 is just 2, compared to like 3, or any other fast growing function that we normally know of, or the famous one. They grow very quickly, or the busy beaver. But Rayo's number seems to go very slowly. Well, this is again because for the first order set theory, it is it's very ineffective in writing down small numbers. However, as you use more and more symbols, it becomes more and more effective. And as a matter of fact, it is extremely effective in creating big numbers. But for small numbers, it's very inefficient. That's why for, let's say, Rayo 50 or Rayo 100, you're still getting very small numbers, which is kind of surprising to me and most people. And there are people out there actually prove that Rayo 835 plus 96N is greater than 2 double arrow N. And again, later on, it was reduced to Rayo 728 plus 75N is already shown to be greater than 2 double arrow N. And later on, some people also proved that Rayo of 731 plus 65N is greater than 2 double arrow N. And as a result, using this definition or this proof over here, it can be, therefore we can tell that Rayo 796 is bigger than 2, Rayo of 861 is bigger than 4, and Rayo 926 is bigger than 16, and Rayo 991 is bigger than 65,536, and Rayo 1056 is bigger than 2 to the power of 65,536. And some person argue that Rayo 10,000 is actually greater than 2 3 arrow 65,536. So far, I mean, it's not very impressive so far because, Rayo's function we now know is uncomputable. There's no algorithm to calculate it, and this, Rayo's number is one of the biggest number ever created or ever named. But how come, but so far it's not very impressive, even Rayo 10,000, this is definitely not a very, very, very big number in terms of the mathematical world, but in the world of big numbers. So you may ask, so how do we know that Rayo N is big with a big enough N? So even, I don't know, you may think that 10,000 is kind of big already, but the result is still not very impressive. So how do we know that? It's basically based on a very simple argument. So actually, the reason is that the BC Beaver function, I think most of you, you probably know about that already. I make a video on that, you can check that out. And basically, the BC Beaver function can actually be defined or constructed using a few million symbols using the first order set theory. So using these symbols over here, in order to create or define the BC Beaver function, you need a few million symbols. So far still not very impressive, but again, this is the important part. And because we all know that the BC Beaver function is a very, very fast growing function, it actually grows faster than all computable function. And what it means is that if you can define the BC Beaver using a few million symbols, so in other words, if you allow to use more than a few million, let's say 10 million or 100 million symbols, that means you can create a function that is way, 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 way more powerful than the BC Beaver function. And of course, Rayo's number is a Rayo with a Google symbols, and a Google is way, way, way bigger than a million or 10 million or even a billion. So using that logic, we can already tell that Rayo's number, at least if you're using very big N, is going to be the number that you get for Rayo N is going to be extremely, extremely big, way bigger than any, most numbers you can think of. And this is basically the reason, because if you can define a function with a few million symbols using the first order set theory, and that is already, since that is how the BC Beaver function is defined, so that means if n is bigger than a few million, that means that is already bigger than, you can already create a function that grows faster than any computable function. That means that function would be already grows much faster than the tree sequence or the gram sequence, the G sequence, and also the SCG or the lotus function. You can easily beat that if you allow to use a million symbols. And don't forget, Rayo's number is a Google symbols. So that means at the end, it just as again, if the more symbols you use, it just way more powerful your function can get using the first order set theory. So that is the explanation, or I mean some of the values of the Rayos number and why it is so big if you're using very big n. So thanks for watching and have a nice day.